I'm Liz Rice, and on a recent video here on the Aqua Security open source channel, I showed how by default Kubernetes will store your secrets in etcd in plain text. So today I'm going to show you how you can set up Kubernetes to encrypt those secrets as they're stored in etcd. There's a couple of little traps that you might potentially fall into, so I'm going to show you those as well. So, if you want to set up encryption for secrets, you need an encryption configuration YAML file like this. So we're defining encryption configuration. We are only going to apply this encryption to secrets resources. And we have a list of encryption providers. The one we're going to use is AES CBC. And then there's also a fallback of identity, which is really leave the secret as it is in plain text. So for the encryption provider, we need a secret, and this is going to be a base 64 encoded string. So let's make up a string. What if I were to say, hello world, and base 64 encode that, and we'll take that string and define that as the secret that we're going to use as the encryption and decryption key for this encrypted secrets that we're going to put in etcd. Now we also have to tell the API server about that encryption configuration file, and we do that in the manifest for the API server. Okay. And I just have to add this line here saying the encryption provider config is in that YAML file that we just created. So I'll just comment out that, or rather uncomment that line. So because that's a change to manifest for the API server running as a static pod, and kubelet will spot that that manifest file has changed, and it will restart the API server with that configuration. So, can I get nodes? At the moment, we don't seem to have an active API running. And if I look for kube API, oh, I'm missing grep. There's no API process running at the moment. So we can look at the logs to find out what's happening. These are in var log pods. API server. And pretty near the top of this log, we can see error opening encryption configuration file. And the path looks like exactly what we specified in that manifest, but it's saying no such file or directory. And the reason is the API server is running in a pod. So it doesn't necessarily have access to files on the host, and our configuration file, the encryption configuration file, is on the host. So we're going to have to mount the directory into the pod so that it's able to access that file. So let's edit the manifest, and down here we should find some mounts that I'm just going to add back in. I'm going to use the same path inside the container and on the host. So here's the host path. There it is, the same path. So again, we've updated the manifest for the API server, and the kubelet should spot that, and it will attempt to restart the API server. So let's see if it's up and running. Still no API. Still no kube API server process. So let's have a look at the logs again. All right. So let's have a look at the logs in the API server, see what's going wrong this time. And again, near the top we have an error, but it is a different error this time. It's saying an error while passing that configuration file. and there's an invalid value. The secret is not of the expected length. So I passed in base64 encoded version of hello world, and it says that that's 11 characters, but it needs to be one of 16, 24 or 32. Okay, it thinks it got 11 characters. By my count, hello world is 10, so there must be either a new line or a null termination or something counted, but never mind. If I echo a 15 character string, 789, A, B, C, D, that should be 16 characters when we use that in our encryption configuration file. So let's edit the encryption configuration and replace this secret with this. And again, it might take a few seconds for the kubelet to restart the API server and pick up this new the new version of the encryption file, encryption configuration file. Let's see if we've got an API server process running yet. We do. There it is. All right, so can we use the API? We can. Great. So let's look at some secrets. I have a previously existing secret here called my secret. Now, that existed before I set up encryption. And let's just take a look at the contents of that. We'll get it in YAML. And the data in this secret says there's a password and the value is base64 encoded again. Let's decode that. Oops. Base64 decode. There we go. The pre-existing secret had the contents really, really secret. I'm going to create a new secret now. And this time it's going to use encryption. So create secret. It's a generic type of secret. I'm going to call this one my new secret. Create it from some literal text. And I'm going to say this time password is it encrypted yet? Okay. And if I get this secret, my new secret, it looks exactly the same as, I mean, it's different values, but it's the same interface as when we looked at a plain text secret. The secret is here, base64 encoded. Let's just check that value. It is the string that we expect. Is it encrypted yet? So the interface that we get when we're using the Kubernetes API, when we're using kubectl, is exactly the same whether or not we're using encryption. It doesn't change anything from the point of view of the user. But the interesting thing is what's happening inside the database file. So we can look at this database file. It's a binary file, but we can take a look at it anyway. It might not be very pretty. No, it's var libetcd, and here's the database. Okay. So if I look for, let's look for my secret first. And this is the secret that we had defined before we set up encryption. And you can see there is the plain text version of that secret unencoded inside the etcd database. So anybody who can look at this database file would be able to read out that secret value. Now let's look for my new secret. And we're not seeing anything. Let's actually search for is it encrypted. We're not finding the is it encrypted yet string. But if we look for that my new secret, we do find this string here suggesting that it's encrypted by Kubernetes using AES-CBC with the key 1 value. And this is what Kubernetes is using to figure out which of the list of different encryption providers to use if it wants to decrypt this string again. So the encryption tells Kubernetes to store the secret encrypted inside the etcd database. We haven't encrypted the whole database, we've just encrypted the secrets where we had encryption turned on for those secrets. And any pre-existing secrets, if they were created in plain text, they're still going to be in the database in plain text. The Kubernetes documentation has some really good descriptions on how you can replace any pre-existing plain text secrets with the encrypted versions when you turn encryption on. And it also tells you how you can rotate the secret that you've used for encryption and replace all your previously encrypted secrets with new versions updated with the new key or encrypted with the new key. That's all covered really nicely in the Kubernetes documentation. So I hope that in this video you've seen how you can use encryption configuration to tell Kubernetes that it should encrypt secrets and how you configure the encryption provider. Don't fall into the trap of failing to mount the directory so that the API server can read that configuration file that you pass it. And also watch out for any error messages that might say you need a particular length key for the encryption secret. I hope that's helpful. Let us know in the comments or on Twitter where I'm Liz Rice. Thanks.